Okay, guys. Today mm, we'll discuss the differential equations and its role in science, engineering, and technology. See, in case of engineering students, or in technology students, or in science students, the beginning level of the differential equations, we become very confusing at what is the differential equations. And we can also observe here most of us engineering students and technological students or science students, we are not able to attract them towards the mathematics, maybe in the differential equations or any other mathematics. The reason is that we are not able to give the systematic information regarding the mathematics to the engineers, to the science students, and to the technology students. The purpose of this lecture is that how differential equation uh, can play an important role for the development of any technical instruments, designing of different type of engineering equipments, or how differential equations can play a role for the benefit of the society. So differential equations, most of us, if we ask about the differential equations, what we do that generally we give the definitions of the differential equations which is available in the textbook. That's why again we become confused that if someone trying to understand the differential equations, we become again confused how we can define it. Okay, most of our case 90 to 99% students can solve the differential equations without knowing what is a differential equation. We solve it. That's why we are not able to attract it toward the differential equations. The purpose of this lecture is that how differential equation can be formed, how it is useful, how we can implement it for the benefit of the society. See, if somebody asking that, what is the differential equations? Most of us become very confusing to define the differential equations. We become very confusing to define the differential equations because in the textbook it is not written clearly in very systematic manner. So now if I want to define what is the differential equations, see, the differential equation can't represent the system. The system may be any of the system. For example, it may be biological system, right? It may be a petroleum system. It may be a reservoir system. It represents a system. For example, if I want to understand the fluids which is flowing through a porous media in the petroleum reservoir, how can I represent it? How the fluids? The fluids may be oil, gas, and water. If they are flowing through a porous media in the petroleum reservoir, how can I represent it? To represent the fluid flow through the porous media, I need the differential equations, right? For example, if I want to represent the blood flow in the human body, in the human system, how I can represent it? I can represent the blood flow in the human system. It has to be represented by a differential equation. So it means that to represent, to give the description of a system is a differential equation. It may be biological system, it may be a petroleum system, it may be a reservoir system. This is the differential equations. Now, if I want to apply the differential equations, it may be in the case of reservoir system, it may be in the case of any other system, for example, biological system. I should understand the science behind it. For example, if I want to represent the fluid flow through the porous media in the petroleum reservoir, what should I do? I should understand the system. What is the system? The reservoir system. I should understand the reservoir system. Then only I can develop an equations, right? The equations can be different type of equations. Mainly, it is a differential equations, right? Now, if I want to talk about the differential equations, if I want to talk about the differential equation, if I talk about the differential equations, right, it represents a system, right? It represents a system, right? It represents the system, right? It may be a reservoir system, right? It may be a biological system. It may be a different type of system. Now, if I want to talk about a fluid, right? Fluid flow through a porous media, through porous media. If I want to represent the fluid flow through a porous media in reservoir system, I want to represent one differential equations which can represent the fluid flow through the porous media in the reservoir system. How do I can represent it once I can understand the reservoir system. It means that I should understand the science behind in the reservoir. What are the parameters? If I want to represent the biological system, I should understand the human biological system. Then only I can write a differential equations which can represent the blood flow through the human bodies. Okay, this is the basically we define in the physical meaning of the differential equations. Okay, now if I come up here in my next slide, mathematical model and mathematical modeling. Now you become very confusing that I just spoke about the differential equations. I was just spoke about the differential equations that it represents a system, right? Suddenly, in the second slide, you have observed that I talked about the mathematical model and mathematical modeling. How it is? Be careful here. The mathematical model can be one type of differential equations. It is not necessary that it is only algebraic equations or it is a non-algebraic equations. It can be a differential equations, right? A mathematical model is a description of a system using mathematical concept and language. Got my point? Now, if I represent the petroleum system, if I represent the reservoir system, if I want to describe the fluid flow through the porous media, I should develop one mathematical model. This model may be known as the governing equation. The equation may be a differential equations, it may be a algebraic equations, it may be other equations. But in today's lecture, we are talking about the differential equations. It means that I talked about the mathematical model, which is going to be give a description of the system of the reservoir system. It means that I am going to develop one differential equations. This is a partial differential equations. So this is the model or equations. Now, what about a mathematical modeling? Now, the process of developing that differential equations, the process of developing that mathematical model is called the mathematical model, right? Now, the mathematical model, don't confuse that the mathematical model and differential equations are different. No. The mathematical model can be a differential equation It may be a partial differential equations. It may be a ordinary differential equations. It is an equation, right? And it is not necessary that the mathematical model is only the differential equation. It may be some algebraic equations. It may be some other equations. But today's lecture, we are talking about the differential equation. So the model represent here will be and equations which represent the system of the reservoir, which can be represent the system of the human body, which can be described the system of the reservoir engineering. So we are talking about a mathematical model means here we are going to develop and differential equations which can represent the different type of system. Okay, but the model can be applied in natural science, it may be in engineering, it may be in technology. In different cases, we can develop a model, we can develop an equations. Okay, now how we can develop now mathematical model? In direct sense, if I talk about that, how we can develop and differential equations, how we can develop a partial differential equation or a ordinary differential equations, or in other languages, how we can develop a mathematical model. It means that we should understand the science behind it. Now, for example, if I want to develop a model, if I want to develop a partial differential equations in the reservoir system, then I should understand the science behind it. What is the science behind in the reservoir system? I should understand it. Then only I can develop a model. Without understanding the system, without understanding all these parameters in that particular system, I am not able to develop the model. I am not able to develop the differential equations. I mean that if I want to develop, I should understand the science. Now, at a beginning level, those students, those who are coming after 10+2 and they took the admission in science, in engineering, we become very confused. We are not able to classify what is the science, what is the engineering, and what is the technology. That's why before starting the applications of differential equations in science, engineering, and technology, I want to give a brief description. What do you mean by science? What do you understand regarding the engineering and technology? I'll give a brief description about it. But before it, if I develop, suppose, a model, which is called a mathematical model, in our case, we talk about the development of the differential equation. It may be partial differential equation. It may be a ordinary differential equations. After formulating the differential equations, we have to impose our conditions, right? So how we can impose the conditions? It may be initial conditions, it may be boundary conditions. In that case, the method is called a mathematical simulation. What is the mathematical simulations? Is a process to identify and predict the behavior, performance, and optimization of some physical or abstract system corresponding to the various scientific and engineering applications. Mathematical simulation means what? Suppose I have developed a model. Model, I mean that it's a differential equation. Now, as per the engineering problem, they're talking about as per the engineering situations. For example, in the reservoir system, in the petroleum reservoir system, how can I do the simulation? I can do the simulations as per the situation arise in that particular reservoir. I should give the initial conditions. I should give the boundary conditions. Accordingly, I can get the solutions of the given differential equations of the given model. It means that in the very simple language, if somebody talking about a mathematical simulation, it means that we impose the situation, we impose the conditions in the model, whatever we have developed, as per the situation of the system. Okay, this is the mathematical simulations. So mathematical model and simulation Means first I have to develop the a model, it means differential equations. Then I have to solve it and I have to impose the situations, conditions as per the situations of that particular system. This is called a simulations. Now here, is it possible? Is it possible without understanding the science behind it? See, I can develop the differential equations of a particular petroleum reservoir system if I have idea regarding the parameters. Parameters means if I can understand the science behind it in that particular reservoir. So I need to understand the science behind it. Then I can develop the technology. Then I can develop the engineering. Now, if I do the integrations of science, technology, and engineering, if I am able to do the integration, then only I can apply for the benefit of the society. They are not independent. Science, engineering, and technology and mathematics, they are not independent to each other. They are dependent to each other. Now, if I am not able to integrate, if I am not able to do the integrated study, science, technology, and engineering, I cannot do the benefit for the society. That's why I'm trying to understand what is science and what is technology and what is engineering and what is the role of the differential equations, how differential equations can do the integration of science, technology, and engineering. My main purpose is that how differential equations can do the integrations of science, then technology, then engineering for the benefit of the society. This is my purpose of this lecture here. Now, before going ahead, we should understand the science. Most of us become very confusing what about the science. We are very much confused what about the technology. We are very confused what about the engineering. The very simple definitions, I don't want to read the slide here. You can read here slide. What is the meaning of science? It is coming from the scientia, right? Which means it is a knowledge. Science is there. Science is the understanding of the natural process, right? How the river flowing from top to bottom, right? We need to understand the natural phenomena. This is called a science, right? Now, if we can observe the natural phenomena with the objective of discovering new principle and knowledge of natural phenomena, it means that if we observe the natural phenomena, not artificial, if we observe the natural phenomena, right? After observing this phenomena, if we can discover some new principle, right? This is called a science. It means that if I want to do the reservoir simulation and modeling, I should observe the natural phenomenon, what is happening inside the petroleum reservoir, right? I should observe there. I should observe the natural phenomenon which is happening inside the petroleum reservoir. I should observe what are the parameters, right? What are the parameters and what are the roles of that parameters that control the system of the petroleum reservoir. If I do understand, if I do observe that system, this is called a science. Science is the observation of the natural phenomena. And after observing, we need to discover some new principle, right? Now, over the natural system, we cannot implement it 100%. We need to manipulate it, right? Now, for example, if I observe the science, if I observe the natural phenomena in the reservoir system of the petroleum reservoir, I have gone some observations. I have received some observations, right? Then I'll discover some new principle that how this science can be implemented for the benefit of the society. Then become the technology. First, observe the natural phenomena, right? Then we try to develop, we try to discover some new discovery, right? Now, what we're trying to make, we are trying to manipulate that natural process. We are trying to manipulate the natural process for the benefit of the society, right? See, technology is the practical application of science to commerce or industry. What it means that whatever you had observed in the science, this was the natural phenomena. I observed it. After observing, I want to apply this natural phenomena, right, for commercial purpose or for industrial purpose, right? It means that I need to develop some techniques. I need to develop some skills, right? And knowledge of the manipulation of the nature for human purpose. It means what? I need to observe the natural process, which was called a science. Then I am trying to manipulate it as per the requirement of the human purpose. For the benefit of the society, I need to manipulate it. Means I can develop some skill, I can develop some techniques, right? I can develop some new idea. This is called a technology. Now, what about the engineering? What we did there, in the science, we have observed, we have discovered. In technology, we try to apply the science, practically apply the science to the commercial and industrial purpose. That includes, it may be skill development, it may be knowledge, it may be techniques, maybe some new methods, right? It may be some new idea. So we develop it. How we can develop it? By manipulations of the natural process. Now, coming to the science, technology. Lastly, we come here now, engineering. What engineering will do? According to the requirement of the society, now observing the science, developing some skill, some techniques, some ideas, some methods, we are trying to design and create some new tools, some machines and system for practical human means by exploiting the technology. Got the idea? We observe the natural process, which is called a science, and we develop some skill, some model, some techniques, some methods, some idea. This is called a technology. Then we design, we create, right? We produce some new tools, maybe machines and a system for the purpose of the society. This is called engineering. So we have to design, we have to create, right? Or we have to produce some new tools. It may be machines, right? And maybe systems. Why? For the purpose of the society. So this is the difference between science, technology, and engineering. Now, our aim was that differential equation and its role in science, technology, and engineering. See, single differential equation can integrate it. A differential equation cannot be developed without the concept of science. That's why, what was the science? Science was talking about the observations of the natural phenomenon. So we have observed. After doing the observations for the society, for the useful of the human purpose, we develop some new skill, we develop some new methods, techniques. Then after getting the techniques, skills, and solutions, we try to create some design, we try to create some tools, we try to produce some new systems that can be applied for the society. So this is called like engineering. So I have those who are coming newly in the science stream, maybe in technology stream, maybe in the stream, they can classify the science, technology, and engineering. So once we clear the science, technology, and engineering, come up here now. I'm talking about here integrated approach for societal needs. What is the meaning of integrated? I'm going to integrate the science with technology, with the engineering. Without the integrated science, technology, and engineering, we are not able to do any benefit for the society. So we need to do the integration of science, technology, and engineering. Okay, how it can be? I want to take one small case study where the role of the differential equation can be defined here. What is the role of the differential equations, right? A differential equation, whatever I'm going to discuss in the case study, can help to integrate the science, technology, and engineering. Now come up here. Mathematical modeling and simulation for 1D, one-dimensional, two-phase flow in petroleum reservoir. Right? Mathematical modeling. What was the process of the mathematical modeling? The definition was that the process of developing of mathematical model is called the mathematical model. What was the mathematical model? It is the representation, it is a description of the system, right? It may be a algebraic equations, it may be a differential equation, right? Here we are talking specially about a differential equation. It means we'll develop one differential equation, right? What was the simulation? A simulation is that we have to solve it by using the different type of conditions as per the system. Okay. After getting the solutions, we need to do the interpretations. As per the interpretations, we need to create the tools system for the societal needs. Okay. Now, if I want to develop the mathematical model, indirectly, if I speak about the how to develop a differential equations, it may be partial differential equations, it may be ordinary differential equations. We should understand the system of that particular system. Here, I took the case study of the reservoir system, which is petroleum reservoir system. Now, if I talk about the petroleum reservoir system, I should understand the science behind in the petroleum reservoir system. What are the parameters that can play a role in the system, right? So how the fluids are flow through the porous media in reservoir, petroleum reservoir. Two-phase means we are taking oil and water. If three-phase means oil, water, and gas, right? Now come up here, mathematical model and simulation, right? Or mathematical modeling and simulation for one dimension, two-phase fluid flow in reservoir system or petroleum reservoir. It means that basically we are going to develop a partial differential equations. That differential equation will represent the system of the reservoir system, how the fluids can flow. What are the parameters that determine, that describe the system of the petroleum reservoir? Right? What are the parameters? Means we need to understand the science behind it. If I can understand it, I need to develop new technique, new methods will become in technological part. Then, as per the requirement of the society, we have to create, we have to develop tools, right? It may be some new tools for the benefit of the society. Now, if I talk about the petroleum reservoir system, what are the parameters? If I talk about the petroleum reservoir system here, if I talk about the petroleum reservoir system, see, if I want to represent the petroleum reservoir system, I should understand the science behind in the petroleum reservoir system. What are the parameters? What are the major parameters that can describe the petroleum reservoir system? Then only I can develop a model. What is the model? It describes the system. In our case, it is a petroleum system. What are the parameters? It may, one of the parameters may be porosity. One of the parameters may be porosity. One of the parameters may be permeability. Permeability, right? There may be viscosity, right? Porosity, capillary pressure, right? These are the here viscosity. There are a number of parameters we can describe the system. Now, I have to develop by using all these things one differential equation. So I have to develop one differential equation. I have to develop one differential equation. The parameters are C, porosity, permeability, capillary pressure, viscosity. There are a number of parameters. That parameters control the petroleum reservoir system. It means that we have observed here there are a number of parameters. It means we can get a partial differential equations. Okay. If I look here in the petroleum reservoir system, the system is controlled by more than one parameters. One of them is porosity, permeability, capillary pressure, viscosity, and blah blah. It means that the petroleum system, reservoir system, can be defined by differential equation by all the parameters, right? There are more than one parameter, so we have to develop one partial differential equation. We have to develop one partial differential equation. That partial differential equation will describe the petroleum reservoir system, including the parameters porosity, relative permeability, capillary pressure, and viscosity. It means that the step number one. What is the step number one? Step number one is that we need to understand the science behind in the petroleum reservoir system. We need to understand science of the petroleum reservoir system. We need to understand the science of the petroleum reservoir system. Okay. After understanding step number two, what should I do in the step number two? In the step number two, I have to identify the parameters. I have to identify the parameters that control the system, right? I need to understand the step number one, science of the petroleum reservoir system. I have to identify the parameters that control the system, right? In the step number three, I have to develop and partial differential equation and partial differential equation, right? Which describe the petroleum system. Okay. So now this partial differential equation is called here mathematical model. So don't confuse. Then if I develop one partial differential equations, right, by understanding the science behind of the petroleum system, right, by identifying the parameters that control the system, I have developed one partial differential equations, right? That partial differential equations can describe the petroleum reservoir system, and that partial differential equation is called the mathematical model of that petroleum system. This step 1, 2, 3. This is called the formulation of, right? This is called the formulation of. This is called the formulation of the model, right? This step number 1, 2, 3 is called the formulation of the model, right? Which is also called the formulation of the problems. It means that by understanding the science of the petroleum system, we have developed new techniques, right? We have developed one equations. That equations represent the petroleum reservoir system. So we can develop one partial differential equation. In our case, that partial differential equation is known as the mathematical model. Now come up here. What are the details parameters where we should understand to develop this model? These are the oil saturation, gas saturations, because we're talking about the petroleum reservoir system. So the parameters can control are all these things, right? Water saturations. So these are the all parameters are here. Look here. Capillary number, right? Fluid viscosity, fluid velocity, all are the parameters. Including all these parameters, will develop one model. This model is called the differential equation, which is a partial differential equations. Now come up here. These are all parameters. That parameters control. That parameters controls. That parameters describes the petroleum system. Now, by understanding all the petroleum system, then we develop one equations. Now come up in my slide here. What is the objective? What was the objective? Objective was that to formulate the mathematical model of one-dimensional two-phase flow in the heterogeneous porous media with considering the effect if capillary pressure. Means our objective was that we have to develop a mathematical model which is a partial differential equations. Okay. Second, to estimate the numerical solutions of the mathematical model using the MATLAB algorithms. First, we have to develop the partial differential equations, and we have to solve the differential equations with the help of MATLAB algorithms, right? Next, to understand the pressure distributions and water situation distribution along with the length only, because it is the one dimension. So what is the pressure distributions? What is the water situation distribution along the length? We have to predict this one. It means that we have to do the simulations. First, mathematical model, we have developed it. Then we have to do the simulation. Simulation means we have to solve the differential equations with the help of initial and boundary conditions. Now, I hope you are very much clear that how differential equation can play very important role to understand the petroleum system, how we can find out the how we can predict that how the pressure can be distributed, how the water saturation can be distributed here. So our purpose was that develop the model, it means differential equations, solve with the help of MATLAB algorithm using the numerical technique. Next model was that we have to understand the pressure distributions, right? We have to understand the water saturation distributions along with the length only. So this our objective was that. Now look here, formulation of mathematical model. Today I am not going to solve it. I will do only formulations, how we can formulate the differential equation. In the next class we will solve how we can solve the partial differential equation. It means will become the simulation part. You look here, formulation means we have to develop the partial differential equations. We have to develop the partial differential equation, which is also called the mathematical model. Right? How can I develop the model? By using the systems parameters, by understanding what are the parameters that control the petroleum system. Okay. Now look here. Consider a one-dimensional, two-phase heterogeneous porous media. If two immiscible phases are present, the equation describing the flow of the wetting phase and non-wetting phase are this. This is the equation. Look here, this is the partial differential equation, right? What is alpha? I have defined in the previous slide. What is rho n? I have defined. What is the Vn? I have defined here. Del y del x. This is the partial derivative with respect to x. X represents the length, right? One dimension length here, right? So what is phi? I have defined. What is alpha? I have defined the previous slide. What is rho n, s n? I have defined the previous slide. Del by del t. It is partial differentiation with respect to time. Okay. Next, it is for non-wetting phase, right? It is for wetting phase, right? The suffix n represents the non-wetting phase. W represents that it is the wetting phase. Same equation we can get for non-wetting phase and wetting phase. So this is coming, right? How it is coming? By understanding the petroleum system, what are the parameters that control the petroleum reservoir system, we can write these two equations. Now come up here again, because we have to implement as part of science behind in the petroleum system, right? Right? We have to modify the equations as part of our requirements. Means we are going to the now development of the new techniques, new skills. Means we're approaching now towards the technology. Whatever we have wrote the equations, we have observed the natural process, means we have observed the petroleum system, we have identified that these are the parameters: porosity, permeability, density, viscosity, capillary pressure. These are the parameters we have identified in the science section. In the technology purpose, in the technology sections, we have to manipulate the system, right? We have to manipulate the system for the benefit of the society, for the practical applications in commerce or industry. Look here, we have to look now here. We have to now look here now, new idea, new technique we have to implement now. We write Darcy's law now, right? Using the relative permeabilities and the equations of the velocity of the fluid for both phases are given here, right? Those who are petroleum engineers, those who are studying the petroleum science, those who are studying the mechanical engineers, they can understand this equation very clearly here. It is wetting phase and it is not wetting phase. What is capital K? What is small k and mu? Everything is discussed in the previous slide. You can go in the previous slide, so you can get all the shit here. There are all the descriptions I have given here in this slide. In this slide, you can get everything here. So come up here. Now look here. By using the both equation together. Now what we are trying to do that. The value of V here, I am trying to put here. Just look here, right? We try to put the value of V here. Just look in the previous slide. The right hand side is at this, right? And the left hand side, I put the value of V. This is the value of V. I have put it here, right? I have put the value of V here. For the non-wetting, I have put it the value of V from here. Just put the value of V here. After putting, I can get these two equations. Okay. So from the Darcy's equations, I got the value of V. From here, I put it here. From here, I have put it here V. After putting here, I can get two new equations. One is for non-wetting phase, second is wetting phase. But for the horizontal one, dimensional flow, depth is same. If it is one dimension, it is a horizontal. The depth is constant, right? If I take one dimension and if it is only horizontal, the depth is constant. Okay. So we can neglect the gravity effect. The value of gravity can be neglected, and only capillary pressure, right, affected. So this equation have come here, right, and these equations have come here, right. It is for a non-working phase, it is for working phase. Okay, after coming here, formulation of the mathematical model, still we are doing here. Now we assume that because it is very lengthy to write every time, so I represent this term is AR, right. So I can find out the derivative of this, so I represent this is BR. What is the BR? This is the partial differentiation with respect to x. Okay, and suppose this is equal to this. We assume all these things, but for numerical simplicity, take gamma is equal to 1. Now, have you got the definitions of the technology? What was the science? Science, we have observed the natural phenomena, what was happening in the petroleum reservoir system. Technology, we are trying to apply that phenomena, right, for commercial and industrial purpose. So if I'm trying to implement it, we have to do some manipulation. We have to assume so we have assumed gamma is equal to 1. We are not putting the exactly natural phenomena. We are doing here some manipulation. We assume gamma is equal to 1. We are in the stage of technology path, right? Now it is simplified in this format. If I take gamma is equal to 1, by putting all these values, we get a new equation. Put the value of AR, put the value of BR, gamma is equal to 1. Our equation, this equation and this equation come this form and this form. Okay. Now look here. But capillary pressure is defined as difference of the working phase pressure and non-working phase pressure. It means PC, this is called like capillary pressure, is equal to P and minus PW. Okay. By subtracting both equations, we get the capillary pressure. We have subtracted this minus this. If I subtract this and this, why we are subtracting here? We are talking about the capillary pressure. The capillary pressure is the pressure difference between non-working phase and working phase. So we have subtracted this minus this. So we get this equation. What is this? This is a second order partial differential equation. Del 2, right? Del x squared. It is a second order partial differential equation. Okay. Now, if I do the simplification of these equations, I can get these equations here again. What is RC? I want to represent. Now, RC means this, where RC is the pressure gradient or change in pressure with respect to the length. Okay. Now, problem statement and initial and boundary conditions. Today, I'm going to stop here. The next class, the next lecture, what I'll do that, we are now up to technology stage. In science, we have observed a petroleum reservoir system, right? In technology, we assume some values, means we manipulated it, right? Our next job is that we have to do the simulations. Now we have to do the simulations. In the simulations, we input initial conditions, we input the boundary conditions, that we can get some solutions. We can get some solutions, hence we can predict the behavior of the system. We can predict the performance of the system, okay? Or in our case, we can predict the pressure distributions, we can predict the water saturation distributions. So today, I'm going to stop here because the lecture becomes too much lengthy here. Next class, what we'll do that, science we have understood, we have predict the parameters, we have identified the parameters, we develop the differential equations, Next job is that we have to do the simulations. We have to solve it by using the different type of numerical technique. One of them is finite difference methods. We can do the finite limits method also. So next class tomorrow, what we'll do that from this slide number 16, we'll try to solve the partial differential equations we have developed. Whatever we have developed, we are trying to solve in the next class. Now, I hope in today's class, you have understood that. You have understood that how and equations means how a differential equations can integrate the science, technology, and engineering. In tomorrow, you can get the simulation also. Once we can get the simulations, you can get more clearance there. What is the importance of the differential equations? Have you observed here that the differential equations cannot be possible without understanding the system? Without understanding the science of the system, I am not able to develop the differential equations. I should understand it so I can develop it. Right? After developing of the model, which is the partial differential equations, we are trying to impose number of conditions, initial conditions and boundary conditions to get the mathematical simulations. So today I am stopping here. Next lecture, I'll start from slide number 16, where we try to impose the initial and boundary conditions. Hence, we can predict the behavior of the system. We can predict the performance of the system. In our case, we can predict the pressure distributions. We can predict the water cessation distributions along the length. So this is one of the examples of how differential equation can play an important role in science, technology, and engineering. So next class, we'll discuss the simulation part. So those who are not attending today's lectures, they should look this video. Then only they can understand the next lecture where we'll take the simulation part here. So I hope you have understood that how differential equations is very important to integrate science, technology, and engineering. Thank you very much. We'll meet tomorrow again.